All right, hey guys, today, last day, let's do it. Today is Friday the 12th of June. Last day of work. We're doing page 519, which is this one right here. And then we're going to skip 20 and 21. Then we have 522 to 524 to do for extra practice. I've already alluded to some of the things that that we're going to be doing today in yesterday's video and stuff. And so the idea is that we are going to be converting smaller units to larger units. So again, we're going from something like centimeters to meters. So we're going from something that's small to something that's larger, right? Well, when we go to something that's larger, it's going to be less of them. So therefore, we're going to be looking at reducing the number, or sort of be dividing. If for some reason you're going from a smaller unit to a larger unit and the number actually increases, you're probably doing something wrong, okay? So that should be an easy way to check your work. So let's look at this one here. Let's do this one together. It says, how many quarts are equivalent to 6 cups? So basically, 6 cups is equal to how many quarts, okay? 6 cups equals how many quarts, okay? Well, we know that in 1 quart, there's 4 cups. There's 4 cups in a quart. So if we think about the strategies we've been talking about, now we could draw this out. There's a lot of different ways we could do this, okay? But at the end of the day, I want to talk about using equations to do this. So what we want to think about here is just like we talked about before, what do we have? We have 6 cups, right? This is what we have, okay? What are we going from? Are we going from a large to a small or a small to a large? Okay, well, we're going from cups to quarts. So a cup is smaller than a quart, therefore we're going from a small to a larger, okay? So because we're going from a smaller unit to a larger unit, we're going to divide, okay? Remember, small to large equals division. Large to small equals multiplication that we did yesterday, right? So it's just the opposite of what we did yesterday. So we're going to divide. What are we going to divide by? We're going to divide by the exchange, right? The exchange rate, essentially, okay? Okay, which is 4. There's 4 cups. It's 4 cups to 1 quart. So therefore, we're going to divide by 4, and that's going to equal our number of quarts, okay? So those of you are like, Mr. Smudge is 6 divided by 4. You know, that doesn't work out. No, you're right. It doesn't work out evenly. Okay. But let's think about this logically, how we can make sense of this. I don't need to draw the big 7 to solve this. I do not need to do that. Okay. We've already done this stuff. 6 divided by 4, we can write this as a fraction, right? 6 divided by 4 is equal to 6 divided by 4, or 6/4. So we get an improper fraction. Okay. And again, hopefully we can convert it directly from here, but if we can't, this helps us. 6/4 is equal to 1 2/4, which is equal to 1 1/2 quarts. And there you go for your final simplified answer, right? You can possibly draw this out if you wanted. You could look at this as, well, if there are 6 cups, I can make a group of 4 cups, cup, 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 cup. This equals 1 quart, right? Then over here, if I do the same, I can put a cup here and a cup here. There's 1, 2, 3, 4, 5, 6 cups. And therefore, this would be half a quart, okay? And I can kind of model it in different ways as well, okay? All right. All right. Let's go ahead and jump over to 422. Again, if you want to look at some of these models and stuff, the model and solve it stuff here, obviously do so. All right, let's go ahead and keep working here. Okay. How many kilometers is equal to 800 meters? Show your work, right? So we know that, now this doesn't give us some information here, so we need to think about some information here. This doesn't give us the exchange rate. So we got to ask ourselves, 1 kilometer is equal to how many meters, okay? We have to ask ourselves that question first. Okay? This right here will be our exchange rate that we need to know what this is in order to do this. Well, okay, kilo means 1,000, okay? And so it means 1,000 meters, so therefore it'd be 1,000 meters, right? Okay. So a kilometer is equal to 1,000 meters, okay? And so what we're gonna do here, if we take that strategy that we talked about, okay, we're gonna go and look at this, that if 1 kilometer is equal to 1,000 meters, right? And we have 800 meters, that means we have less meters in this, and that means we're gonna have less than, 1 kilometer, aren't we? Does that make sense? And 800 meters is less than 1,000 meters. Therefore, 800 meters is less than 1 kilometer because these are equal. Okay, so how can we do this? This is what we know. We know we have 800 meters. Okay, we want to get to kilometers. So we're going to divide. We're going to divide this because we're going from a small to a large, right? Small to large. And so we're going to divide by the exchange rate, which is 1,000. Oh, Mr. Smotchus, this is really hard to do. Is it though? Number one, we can divide by powers of 10. Number two, so we could literally our decimal points right there, so we can just shift this over 3 place values, right? Or we could just write this as a fraction because it's division, right? Okay. Then ideally, when we deal, by the way, when we deal with metric and stuff like that, typically, I mean, it's kind of nice to write things in decimal form. So that's what I'm going to do. So I have 800 thousandths. I'm just going to write that as a decimal, which would be 800 thousandths. And then clearly I don't need these zeros here, so it's just 8 tenths, right? I could also just simplify this because there's 2 zeros here and 2 zeros here. That means I can divide both these by 100 to get down to 8 tenths. Now obviously 8 tenths could be simplified as far as a fraction goes, but I think I want to leave this as a decimal because again, when we're converting metric in particular, leaving it in decimal form is going to be much better because we can just shift the place value, right? So the answer would be 8 tenths kilometer would be the best answer. And naturally, if we were going to just shift this 8 would move over 3 places. So it'd move over 1, 2, over into the next, I don't really have room for, but using that place value right there, which is to the right of the decimal point, which is the 10th place. And that's how it ended up in the 10th place here as well, right? All right, next. How many yards are equal to 25 feet? Again, this does not give us our conversion, so that's the first thing we need to make sure we understand. Okay, 1 yard is equal to how many feet? Okay, well, the answer, hopefully we know this, is 3 feet, right? So how many yards are equal to 25 feet? Again, so we know we have 25 feet, and we want to figure out how many yards does this equal, right? So blank yards. Now, because we're dealing with the customary, okay, I'm going to write this as a fraction. So just in general, not always, but just in general, leave decimal stuff as, metric measurements like this, meters, whatever, as decimals, and use customary stuff as fractions in general, okay? It just makes life easier, usually. So again, we're going from a small to a large, feet to yards, so a smaller unit of measurement to a large unit of measurement. We're going to divide this by our exchange, right? Whatever the conversion rate is, that's the better term, conversion rate, right? Okay, so again, we have 25 divided by 3. Now, 25 divided by 3 equals 25 thirds. Now, if you need to draw out the big 7 to solve this, that's fine, you can do that. Okay, I'm just going to use some strategy here and think how many groups of 3 can I get out of 25? Well, I know 8 times 3. 8 times 3 is 24. That leaves one group, So 24 from this would be leave one group left over. So it will be 1/3 left over. So it would be 8 1/3. And this would be my answer. Okay. The next question here says, which of the following measures is equivalent to 3,300 grams? So which of, now we can see clearly see all of these are kilograms, okay, or kg, right? Kilograms. Okay. That's all these are. We're going from 3,300 grams. So we're going from grams to kilograms. So we're going from a small to a large. Okay, so we know that our answer here is going to be a smaller number, right? It's equal in value, but it's a smaller number that's represented because the parts are going to be bigger, right? So if we look at this, we have to again think about what is the exchange rate between grams and kilograms. Well, it's the same thing between kilometers and meters, right? Grams is our base unit of measurement for this metric unit of capacity or mass, right? Okay. And so, again, which I know you guys spend a lot of time with Mr. Annan talking about this. So grams to kilograms. So again, it's going to be 1,000 grams is equal to 1 kilogram. Okay, so it's a rate of 1,000. So therefore, I'm going to take 3,300. I'm going to divide this by 1,000. Again, I'm going to leave this as a decimal like we talked about. As you can see, these are decimals over here if there needs to be decimals. But the idea is that 3,300, that decimal point is right there. That means this stuff's going to shift over and get smaller because we're dividing it by, and it's going to be 3 place values, powers of 10, right? 10 to the third, okay? 3 place values. And again, if I decide to just move the decimal point, I would move it, make it smaller, 1, 2, 3. Decimal point would move there, 3.3, or I would shift the other direction. It's going to get me to the same place. C is the correct answer. Okay, I'm just dividing by 1,000, right? And seeing that's the beauty of the metric system, is that we've already learned how to multiply and divide by powers of 10, so we can do this. We should be able to do this. We've done this so many times this year. All right, now we are down to the last bit here, guys. We have page 523 and 524, and that is it. I will look at the first little bit here, kind of again helping review, helping you make sense. I'm gonna leave that last bit for you to finish on your own. Okay. In this example here, how many pounds are equivalent to 56 ounces? Okay. Now it doesn't tell us here initially how many there are if that was just a thing. So if you get run to a problem where it doesn't tell you what the exchange is, then you need to look in your book in another location where it talks about it, or look in your notes that we wrote down the other day. But clearly here we see that 1 pound is 16 ounces. Then it has this table that shows 1 pound, 2 pounds is 32, and so on and so forth, right? So the idea though is that we're at 56. 56 is going to fall between these two numbers. So if this helps you to draw this out, then do that. We've done this before as well. This is not new either. Okay, so we know that our answer would fall between 3 and 4 pounds. Okay, it's not going to be more than 4, but it's going to be bigger than 3. So we know that we're going to have 3 pounds, we're going to have something left over, right? So we know 56 divided by 16 is going to be 3 and something. Well, now obviously the answer is right here for us, right? Okay, we obviously could just do that division as well. But here, looking at this, we can always take out 48 from 56, see what we have left over and relate that to 16, which would be 8. 8/16 is equal to a half, right? So which is the smaller unit, pounds or ounces? Okay, well, between these two, ounces are a lot smaller. So ounces are the smaller unit of measurement. What operation do you use to convert from a smaller unit of measurement to a larger unit? Again, this is what we've been talking about all day today, right? Going from a smaller unit to a larger unit, we're going to use division, right? We're going to use division. So explain how you can use multiplication to check the answer. Okay, to check the answer, right? So if this problem is 56 divided by 16 equals 3.5, in order to check my answer, I would do the inverse operation, right? I would do 16 times 3.5 is equal to what? Okay, now if I do that, I do it correctly, okay, then I should get 56, correct? So, but it says explain, so you can use words. I'm just writing examples, so you take this and but use words to explain how you would do that. Okay, just checking your work. Obviously, should just go say I'm going fairly quickly. I want to get through all this, so it's not too long of a video. But you can pause at any time to do what you need to do. So you might want to pause it to do that now. Number 4, last one we're going to do together here. Use the relationship between pounds and ounces to complete this table. Okay, if 1 pound is equal to 16 ounces, then therefore 2 pounds is equal to 32 ounces, right? Okay, so what is 8 then? Well, 8 is half of 16, right? Okay, so therefore this would be half a pound is equal to 8 ounces. That seems reasonable, right? Yeah. So again, if we're looking at this, we're looking at 16, number of ounces I have, divided by 16 would give me 1, right? 8 divided by 16 would be a half, right? 8 divided by 16 is equal to 1/2. 8/16 is the same as 1/2. So if we look at this one here, it's going to be 20 divided by 16, isn't it? 20/16. Okay. Well, that equals 1, and what's left over here? What's left over? Okay. Well, if I take 16 from 20, I have 4, so 4/16. What is 4/16 equal to? If they're both divisible by 4, 16 divided by 4 is 4, 4 divided by 4 is 1, so we get 1 and 1/4, right? Okay. Naturally, 32, this would be 32 divided by 16, which is equal to 2. Two groups of 16 is that. And then lastly, we have 40 divided by 16. Well, I know that I can get 2 because that's 32, right? Well, what's the difference between 32 and 40? Well, it's 8. So it'd be 8/16. Well, let's convert that. We can simplify that. We already converted this one time today, right? We already simplified, I should say. Not converted, but simplified. Okay. So this is going to become 2 and 1/2. And that's what that should be. Okay. On your own, okay, I want you to solve numbers 5, 6, 7, and 8. It's your last task for math of your 5th grade career. That's it. Okay. I'm going to say this now. I'm going to post this later as well. I'll post this in when I post this link as well. Monday, when you turn your math stuff in, just turn your whole math book in. Otherwise, you have to tear all these pages out, and that's kind of a pain in the butt. If you want to keep your math book of the stuff you have done, I guess, or sorry, I mean, I have all the stuff that you've done in this book, but if you want to keep the book so as there's the undone stuff because you want to practice that over the summer, that's great. Tear the pages out that I've assigned. Make sure you don't miss any of them. But that's up to you. You don't have to. It'd probably be easiest just to turn your math book in. Especially if you know you're not going to do any of that stuff, And if you're unsure, just turn your math book in. You're probably not going to do it anyways, if we're being real. Now, if you know, like, hey, I want to make sure I get this done. I want to get all this extra stuff done, just get extra practice in, whatever. Because there's obviously a lot of stuff, geometry and things like that in these books. Feel free to do that. I'm not going to say no to that, obviously, because I love the fact that you want to do more math. But there are tons of resources online to do that same math. So, yeah. One last note, we have our end of the year ceremony. It's not a Zoom or social. It's not a social like we've done in the past, okay? So just a heads up for that. Expect to be kind of relatively quiet and a lot of listening on your end and watching. We will give you an opportunity to do some things though, okay? It's going to be on Zoom, so be sure to make sure that you check in early to make sure that your computer is up and running and functioning properly with Zoom. You might have to download it. It's really easy to do. It doesn't take long. Okay, we did it on our computers as well. Super fast and easy. Okay, I will talk to you all later.